Okay, so just to introduce myself, just quickly. My name's Steve Cookson. For those of you who've not seen me running about on roofs on LinkedIn and pointing out all the things that we find on there. I've been in the industry for over 28 years. Started off at Icapal, or BMI as it is now, or Anderson Roofing as it was when I joined the company way back when. Also was technical manager at Seeker and technical director at HD Sharmans, who look after metal roofs, gutter liners, things like that. Roberts Group, they are Polyroof and ResTech. I was twice chairman of the LRWA. I'm also a fellow director and chair of the board of the Institute of Roofing. Out of all of that, I think my favourite job is husband and father to 3 boys, 3 growing boys, as you can see. Grow to be a bit bigger than me. I'm not the biggest of guys. And in my spare time, I like to coach these guys. I'm a junior football coach as well for my local side, Hyde United, which is where you'll find me on a Saturday afternoon. Okay, enough about me then. Let's have a look about roofs. Okay, so we're just going to have a look at the most common defects, and obviously we're going to look at the most common kind of roofing waterproofing material. So felt, single ply, mastic asphalt, and liquid waterproofing or liquid applied membranes. So we're going to have a look at those disciplines and the common defects that are associated with them. So the first thing we need to do is obviously identify when we're on the roof what kind of waterproofing we've got. So felt is quite an easy one. It's usually covered in mineral surface. You can see the laps usually, and hopefully with bitumen exuding through those laps. Sometimes you see sanded underlays and cap sheets, but the thing about bitumen is it's not UV stable. So it should be protected by chip-ins or aluminium paint, which is what you can see. So chip-ins in the top right and aluminium paint in the bottom left of those pictures there. That's how we identify felt on the roof. So felt will tend to delaminate at the laps, and there's a couple of reasons for this. And the first one is poor installation. Not enough heat was applied. And there's not bitumen exuding from those laps in a torch-on system, in a pour and roll system. That felt then, that bitumen then can become brittle due to age, and it's most common around the details. But so you can see there, my trusty probe, which I'll go around and probe all of the details on the roof and the laps and everything, and see if we can find any of those delaminating laps. You see there, it's quite a severe case of delamination there. Obviously, underneath ponding water as well. So this roof was leaking. Another common defect on felt roofs, and well, not just felt, is around outlets. We should have a look, make sure that it's bonded around outlets. The safest way to detail felt around an internal outlet is either by the use of a clamping ring, or in case of refurbishment, a refurbishment outlet with a flange on, to make sure that we get a good bond there. But like in these cases, the felt has just been taken to the edge of the outlet. It's delaminated, so any water that's going to back up in those outlets can get back straight underneath the felt and into the waterproofing system, ultimately into the building. So it's just something to look out for. Make sure you're looking out around those outlets. So there's an example of, like I said, a good way of doing it is a clamping ring. So is one that we kind of deconstructed to have a look at it. So the felt is taken into the throat of the outlet and star cut, and then the outlet is tightened, and that area there, just get my pointer, there we go. So this area here is called the clamping ring. This nut is tightened, and then that is tightened around a hook that's on that bar. So it's this felt then becomes nicely compressed, and there's less chance of water ingress there. This is an example of a refurbishment outlet. So another good way of detailing felt outlet is that. So this is called the flange, and this felt flange is bonded to in between the layers, and then the cap sheet is taken up to the outlet there. It's cut around, so you've got a nice seal there, at least kind of 150 mil, to make sure that no water backs up and gets underneath the system. Another common defect that we see with felt roofs is blistering. Now this is going to happen over time. Most aged felt roofs, you will find some element of blistering, and there's a number of reasons why blisters can occur. They're all usually linked to excess moisture within the system. Obviously, moisture will expand and try and force its way out, and that will cause these blisters to occur. The moisture can be from water ingress, it can be from interstitial condensation, a number of different reasons. The most important thing is that we investigate these blisters and find out what the root cause of them is. And then obviously when we're putting our remedial specification together, making sure that we eliminate that source of moisture. There's another example of blisters, and blisters can range in size, anything from a small blister, 50 mil, to a very large blister, meters and meters long sometimes. Cracking is another one that we'll see in felt, a common defect. Usually over time, as I said before, bitumen is not UV stable, so the harmful rays from the sun, if left unprotected, will cause this. And in this situation, as you can see, it's just that felt hasn't been protected at all. So you can see these small cracks have started to occur. Again, over time, this mineral surface has started to wear away. So you can see where the mineral surface is wearing away. You can see these cracks, especially along the lap of the felt there. And like I said, over time now you can see this lap is now starting to open up, because this would have been an old pour and roll felt roofing system where they heated the bitumen up, poured the bitumen out in front of the roll, and then rolled the felt into it. So the bitumen would have come to here. But that's become old and brittle over time, and now obviously it's starting to crack. That picture kind of explains it a bit better. So maybe a more of a torch-on system, this where there's a bead of bitumen exuding from the laps, but you can see where that bitumen hasn't been protected. You see that it's starting to crack now and fail just down to kind of UV degradation. This is obviously a larger crack in a bitumen membrane, and this is probably caused due to structural movement and the felt becoming brittle over time. As you can see, again, the mineral surface has started to wear away, so that UV has attacked it. It's become brittle. There's been some structural movement, and that's what's caused that defect there and that crack, to the point where we've started to form a natural green roof in this situation with a tree starting to grow. Okay, so they're the kind of most common defects that we see with felts. As I said, there's going to be some more that you're going to find, but they're kind of the common defects as we see with felt systems. So I'll move on now to single ply. How do we identify single ply when we get on the roof? Well, they're kind of into two categories: plastics, which is your PVCs, your TPOs, lots of different types of single ply out there, and then rubbers, which is the most common one is EPDM. So in the top picture there, you can see that's a kind of PVC membrane. It's light grey. You can see the laps in the single ply, usually kind of 1.3 meters wide. So that's an easy way of identifying single ply. In the bottom picture there, it's black in colour, and so that's usually an EPDM rubber membrane. Again, you can see the laps at those 1.3 meter centres. So that's kind of how we determine single ply. And single ply is either mechanically fixed, fully adhered sometimes, or ballasted, mechanically fixed and then ballasted to hold it down. That's an example of a ballasted roof. And then there's different kinds of fixings. So in the top left there, that's a fixing for the insulation. You can see the washer on there. Bar systems are also used in the top right there. So a bar will be mechanically fixed to hold the single ply membrane down, especially in high wind uplift areas, because it's obviously not bonded to the roof. It's loose laid. And then in the bottom picture there, you can see it's being mechanically fixed at each of the laps, and then those laps will get heat welded to form a waterproof barrier. Just an example there of a design for a bar system. So you can see around the perimeters there'll be more bars because that's where the higher levels of wind uplift will be, in the corners and the perimeters, and then in the field area they're spaced more further spaced apart because the wind uplift isn't as extreme in the middle of the roof. As I said, different kinds of fixings. So you can see on this single ply roof, this is a chemical or a solvent welded system. So these fixings are placed in the insulation. So it mechanically fix the insulation down. The solvent is on the top of here, and then the single ply will be rolled over the top, and then the single ply is then forms a chemical weld at each one of these fixings. That's the opposed to the other way that we said, where you mechanically fix at the laps and then heat weld. These laps again will be heat welded. So a common defect of single ply is obviously if we get those fixings wrong, and obviously they can go wrong due to installer error. And unfortunately, in the new build market, we do see a lot of value engineering and using inferior fixings where pull-out tests haven't been conducted and things like that. So over time, as the roof bellows, which it does with single ply, those fixings can sometimes work their way out. So either installer error, not putting them in correctly, or they can work their way out over time if they're incorrectly specified. So you can see on this roof, you've got your metal deck here with your vapor control layer, but you can see a big gap there between the insulation and the metal deck where the fixings have not been installed at the correct centers. Just a quick video there of what can happen if it does go wrong. You can see the wind uplift and everything there. These fixings have obviously come away from the membrane, and eventually that roof will blow off if we're not careful. On that roof, these were the fixings that we found. So you can see the kind of the hump there, and there were fixings that had penetrated the membrane. So you can see just totally incorrect specification of fixings, or value engineering, or whatever the reason. It's the wrong kind of fixings, and inevitably the roof is going to go wrong. Look out at the details as well on single ply, because they should be mechanically fixed with bars, peel stops, all that kind of thing should be installed. Make sure it's installed to the manufacturer's specification, because they do tend to come away at details and everything like that. So another defect to kind of look out for is the detailing. That's kind of an extreme example of wind loading or wind uplift. That's what's going to happen sometimes if the specification isn't done correctly. Because there's laps in the system, one of the defects is going to be delamination of the laps. Usually with single ply systems, that's not down to age. It's usually down to installer error, because the bond with a single ply system won't fail over time. It's usually that it wasn't installed correctly in the first place. So make sure that we check all of those laps with the probe, just to make sure that you've got a full and proper weld. The welds with single ply should be done kind of in 2 stages: tack welds and then the full weld of the system as well. Blisters, less common in single ply because, as I said, it's seldom kind of mechanically, seldom fully adhered. So there's usually room for any moisture to move around the system. So blisters in single ply are usually full of water, and they are usually caused by an inadequate weld or water getting into the system and then tracking to the low points. So again, blisters in single ply usually found at the low points, gutters, outlets, and places like that. Loss of plasticizer or plasticizer migration, not a common occurrence these days, as the products have obviously been developed to be better. It does still sometimes happen. Sometimes the cause is unknown, what causes that plasticizer migration. So yeah, plasticizers, for those who don't know, is put into the product to keep the products flexible. So those kind of plastic toys that you see in your garden, if they are left over time, children's kind of toys, if they're left over time, you see the plastic becomes brittle. So that's when that product has lost its plasticizer. Like I said, not a common occurrence, but when it does happen, it's quite catastrophic, as you can see in the image there. Mechanical damage, probably one of the most common defects with single ply membranes. Unfortunately, this is purely down to it being a single layer of waterproofing and it being so thin, and kind of following trades will come along if there's a lot of plant on the roof and things like that, come and service that plant, leave nails and screws and things on the roof. They can get trodden on and unfortunately cause this kind of mechanical damage. So it's one of the reasons why I don't tend to favour single ply on roofs where there's going to be a lot of foot traffic from other trades. It's a fantastic and quick system to install on a wide open roof that's never going to get any foot traffic. So it's when I always say it's horses for courses when specifying waterproofing systems. Okay, onto Mastic asphalt. So how do I identify it? Well, it's smooth, it's black or grey, sometimes covered with solar reflective paint. Again, it's bituminous, so it should be protected from UV. And the sun is the thing that will cause the most damage with Mastic asphalt and cause these defects that we're gonna have a look at. Blistering, again, in asphalt is caused by a buildup of moisture underneath, as with any kind of blister. And again, that can be down to interstitial condensation. It can be down to moisture within the substrate. It can be down to when the asphalt is installed. It's installed in 2 coats. So if that first coat is not completely dry, when the second coat goes over the top, then that will form blisters. Cement dust as well from the buckets, and when they actually install it can cause pockets in the asphalt, and they can expand and cause the asphalt to blow. This is obviously a blister in asphalt. These will expand over time. They start off as little bumps in the asphalt, but as you can see, this has got cracks in it now and everything. So this is quite an advanced kind of bump or blister in asphalt. It's not uncommon to see an asphalt roof look like the surface of the moon, and like I said, that can be down to when the product was being installed. It can be down to poor ventilation as well, of perhaps a concrete screed underneath. Maybe screed vents and things should have been installed. But yeah, it's all down to moisture with blisters. Cracks is another common occurrence in asphalt, and again, like with the felt systems, it's down to a couple of reasons: structural movement, thermal movement, and the smaller cracks, as you can see in this picture, is down to lack of protection from the UV. Those trims that are on the edge there at the drip detail have expanded and contracted, and that's what's caused these cracking here. All different kind of elements of the roof there where you're going to find cracking within the asphalt. So have a good look. Have a good look around for cracks. Obviously, cracks are a form or a cause of water ingress. Any moisture is going to get into those cracks, seep into the system, and ultimately into the building. Slumping at the details, again, is quite a common occurrence with aged asphalt. Heat from the sun causes the asphalt to soften. Usually see these on kind of south-facing details, or where there's some kind of reflection from another building. On such details, over 300 mil high expanded metal lathe can be used to help the asphalt to better bond to those, and ultimately the asphalt in the first place should be put on in more coats, so it should be at least 2 coats on an upstand, 3 coats sometimes as well, and it just gives it a better chance of bonding to that kind of metal lathe or the reinforcement there, and not slumping over time. You see the asphalt slumping into the gutter there. The asphalt, you see the asphalt has slumped off this curb here, and then they've obviously tried to remedy that with a liquid patch, for the want of a better description. Movement or ripples that we see in the asphalt. This is again from the heat from the sun will cause the asphalt to soften, and then the weight from anything that's put onto these asphalt roofs. You do see handrails that have been retrofitted. This is obviously, it's been some kind of M&E equipment, and you can see where it's been vibrating. It's caused these ripples and everything here. That's the M&E equipment has now been taken away, but you can see. And even something as light or as small as a PVC downpipe can cause kind of softening and in the asphalt. It doesn't take much really once that asphalt's softened. This is quite an uncommon occurrence. This is what's called thermal shock, and we don't see much of that these days because the asphalt or the systems have added additives into there to make them a lot more elastomeric. So what causes thermal shock is, so this is over a warm roof where you've got your deck, your insulation, and then the asphalt waterproofing over the top. Over time, during the day, the sunlight is absorbed by the asphalt. It's absorbed into the insulation. That insulation then holds that heat from the day, and also the heat from the building as well is held within the insulation. As the sun goes down at night, the temperature drops, so the bottom surface of the asphalt is warmer than the top surface of the asphalt because of the heat that's held within the insulation, acting as a kind of a heat sink, and that's what causes that kind of movement and everything. That's what's called thermal shock. So it doesn't occur too much these days because asphalt membranes and felt, we sometimes see it with felt, but they have been improved over time, so we don't tend to see it these days. But on older buildings, if you see it, at least you know. So liquids, probably the fastest growing sector of the flat roofing market at the moment. It's seamless, it's cold applied, so could be seen to be a better health and safety option. It's easily moldable around detail, so on roofs with a lot of detail, it is an ideal waterproofing method because there's less lapse, and obviously lapse can be seen as a weakness. That's not to say that single plied and felt are not a good waterproofing material. They are, and they will last the test of time if they're installed correctly. There are a few downfalls or pitfalls with liquid. The main one is that effectively what we're doing is we're manufacturing a product on the roof. So there's usually 2 coats with a liquid applied system. The first coat usually has reinforcement within it, and then the second coat is applied over the top. So really, like I say, we're kind of manufacturing a product on the roof. So the workmanship element of liquid is very important. And unfortunately, you can go and buy a liquid off the shelf from B&Q or from Travis Perkins. Anybody can go and install it, and that's kind of what we see in these days with some of the projects that I get called out to. This is film thickness or lack of film thickness, and this is a very common defect when it comes to liquid waterproofing. You can see the glass fiber reinforcement there. So this has not been put on a correct film thickness. It's probably not been put on in 2 coats. So like I say, that's a very obvious one when we're walking around and looking for defects with liquids. And goes without saying that water can get in between all of these fibers. It can freeze and thaw, expand and contract, and eventually it's going to get into the building. This is what's called pinholing. So pinholing is common across all liquid applied membranes, and it's usually caused by moisture within the first coat. So the first coat is applied. Sometimes they can be caused by overworking the first coat. Puts too much air or moisture into the product. Whilst it's still wet, it's going to expand. It's going to cause these pinholes and ultimately come through to the top coat. In the base coat, pinholes can be remedied. They can be filled with PU sealant or other methods before the top coat is applied. Within the top coat, it's important that we then check the top coat for pinholes, and again, we can fill them with a sealant, or we can put another layer over the top. If they are left untreated, this is what can happen. Those pinholes will suck water in. That water then will freeze and thaw, expand and contract. Eventually, it will cause a blister or delamination in the liquid. Again, you can see another example of some pinholes. Cracking, usually, and I say usually, associated with rigid GRPs, not always associated with rigid DRPs. I'm not wanting to tar them all with the same brush, but these cracks are usually down to lack of reinforcement, lack of film thickness, not putting expansion joints in, which a rigid GRP system will need. But another common defect to look out for is cracks within these kind of systems. This is obviously at the joint of an edge trim. So this is a GRP edge trim, that has expanded and contracted, and obviously then it's caused this cracking. So this is due to kind of lack of reinforcement. Maybe this system needed some extra reinforcement over the joints, and that's what the contractor should have done and didn't do. So that's what's caused this cracking, just down to movement. Wicks are another kind of common defect when it comes to liquid applied membranes. Exclusive to GFM or glass fiber matted systems. Other systems have got fleece reinforcements. Obviously, they wouldn't suffer from wicking, but the majority of liquid systems, I would say, have a glass fiber reinforcement. This is an extreme example where it's just not been encapsulated at all. You see the glass fiber there, but you can see these strands here, which are called wicks. Each of these strands has got to be fully encapsulated when it comes to liquids, because what will happen if they're not fully encapsulated and left exposed, they will wick moisture into the system, and again, that moisture will expand and contract, and it will cause blistering and delamination at the details. Talking of delamination, this is an example of that, which is another common defect of liquids. And delamination is usually caused by either poor cleaning or preparation of the substrate that the product is being applied to. So obviously if the substrate is not clean, it's not going to stick. So that's going to cause it to delaminate. There's different primers that are used as well. So different primers for different surfaces. So it's important that the manufacturer's specification is followed and the right primer is used. Then there's delamination between the two coats, which is what's happened here, and that's called intercoat, poor intercoat adhesion, and that's usually caused by the first coat being applied and then being left too long before the second coat is applied over the top. So then dirt or any kind of contamination can go onto the first coat, and it's not clean by the time the second coat is applied. So this kind of intercoat contamination can happen. And again, although most defects are down to installer area, there are perhaps some more things to consider when it comes to liquids. This should be a video, but it's not playing for some reason. So what this video shows is this liquid membrane is still soft. So with liquid membranes, especially with catalyzed systems or two-part systems, it's important to get your mix ratios and your catalyst ratios correct, or else the membrane is never going to cure. And in this instance, it didn't, and it's still soft on this roof. No, there we go. So you can see that liquid membrane there hasn't had the right amount of catalyst installed, so therefore it's not cured. Okay, so that's the kind of defects that are associated with the different waterproofing disciplines. These defects now that we're going to have a look at are kind of common to all waterproofing. So as it says, workmanship and poor detailing is probably the biggest cause of defects on a flat roof, and also retrofitted items, so pipes and cladding and things like that. If they're not installed correctly, then they can cause a latent defect. So they've got to be fit for purpose and correctly detailed, and ideally installed by the original contractor, so that, and with the manufacturer's consent, so that it doesn't affect any kind of guarantee that's in place on that roof. And another kind of good rule of thumb for installing retrofitted items is don't use flash band, because that flash band is awful. It's a budget and Scarpa's best friend, but my kind of worst enemy. So that's another picture of that kind of retrofitted detail. So you see the pipes coming through the roof there, and they've just bodged that with some kind of expanding foam. And like I said, my best friend flash band. So that pipe, that penetration has been put through the roof, and then the flash band has been used there to try and waterproof it. It's not going to last. It never lasts. It's horrible. It should only ever be seen as a temporary measure. Wires and pipes going through curves of roof lights. Again, something else that we see quite often. If you get in touch with the manufacturer, they will design you a detail that will work in with their system. So in this instance, there's what's called cable ducts. A cable duct could have been installed here, welded to the single ply, and then the wires or whatever they are go through that cable duct. The roof's still waterproof, the roof's still guaranteed, and we're all happy. In this instance, what you can see is an asphalt roof with no trim or anything. So there should be an edge trim in place here, but the asphalt has been taken just onto the brickwork. Obviously, over time, it's shrunk back, and any water now can get underneath the system and into there. So a few guidelines to keep in mind when it comes to detailing, and when we're looking at surveying and things like that, when we're looking at defects. So Upstand Heights should be a minimum of 150 mil. Obviously, we'll go into that in a bit more detail. Got to be a bit pragmatic on that sometimes. The material, when it comes to a brickwork or any kind of upstand, if possible, it should be chased into the upstand, so that any water that's going to run over is going to run over the system, and the system is chased into a detail. it should be protected as well, if possible, within those shades, like with lead flashing or something like that. Exposed edges of the waterproofing should be protected. Like in this instance, it's not, so anything can get underneath here. So if there was a trim on here, that trim would have a recess where the waterproofing can be terminated into. So, like I said, the roof should be suitably terminated and protected in all instances, if possible. In this instance, what's happened again? Poor workmanship. You see that they have installed. This is a GRP system. They have installed expansion trims, so that is good. Or expansion joints, so you're not going to see cracking in there. But what they have done is these coping stones here have been leaking in the past. They have repointed them, but there's an old felt system here, so they've chased the trim. I'll show you a bit more detail. Now they've tried to chase the trim into here. They've put a bead of mastic or silicone or whatever that is over the top, but they've just not chased it in far enough, and they've left the existing felt in there. So this roof was leaking at the perimeters. So obviously, when we've investigated, we've found this is the problem. Our solution was to take these coping stones off, remove that trim, remove everything, and then take a waterproofing system up and over that parapet onto the outside edge, and then reinstall the coping stones, making sure that we've got fully waterproof across the cavity, with a cavity closer in there and everything. If we're going to do it right, as George Michael once said. Again, just an example of where felt hasn't been chased into brickwork. So again, it should go into these chases by at least 25 mil, and then that chase should be sealed with mortar or a mastic, or protected by a lead flashing or something like that. We are getting on time wise, so I'll try and speed up a little bit. So that, as I said, the height of upstands, BS 6229, which is the British standard for flat waterproofing, says that upstand height should be a minimum of 150 mil above the finished level of waterproofing. Obviously, it's not always practical. It's not always possible. Ultimately, it's down to the manufacturer, whether they're going to guarantee that detail or whether they're going to say that's going to be maintainable and it needs to be inspected every 12 months. In this instance, you can see it's 110 mil, that upstand. These are, this is a windowsill, and this is a big bank of windows. So to achieve 150 mil, we would need to replace all of those windows. It would be a costly job. So therefore, we say that we're going to live with the 110 mil here. The roof is falling away from that detail as well. So a manufacturer would probably guarantee that detail. Obviously down to them, but in my previous roles, I would have given the go ahead to guarantee that detail as a manufacturer. There's times when we can't. There's times when we need to say nope. We need to raise this detail. As you can see, it's around 90 to 100 mil. The asphalt is coming away. It's a door threshold. The roof is falling towards that door threshold. So when we put a specification, a remedial specification together for that, our advice is going to be to raise that door threshold to be 150 mil and stop the water ingress at that detail. Existing drainage, again, is something that we should be looking out for. Flat roofs usually drain directly into internal outlets, internal gutters to either internal outlets or chutes or hoppers, or drip details to external gutters. With those outlets, it's important to make sure that they are they're performing as they're designed to. Obviously, drainage calculations will have been done for flat roofs, and in this instance, a refurbishment outlet has been put in place, but it's reduced the diameter. The original diameter of these outlets was around 100 mil. This has been reduced to 60 mil. So the roof was leaking at these details. Water was backing up in these outlets and getting up underneath the system. So just have a good check of any kind of internal outlets. It is a source of where you're going to find common defects on a roof. Existing drainage, roof falls, or lack thereof. Again, BS 6229 says that each a roof should have a finished fall of 1 in 80, a design fall of 1 in 40. And just as a rule of thumb, a millimetre of ponding water weighs around 1 kilogram per square metre. So in this instance, where we've got kind of a duck pond, what's happened here, this roof has now started to deflect because of the weight on the roof. It probably started with a small puddle in the middle of the roof, which has deflected over time because of that weight on the roof, and then it's caused more and more deflection. Eventually, the roof is in danger of collapse. You can see that those concrete beams have started to deflect. This is the underside of that roof. You see the outlets are on the external edge here, and the ponding in the middle of this roof was around 100 mil. So if you look at that rule of thumb for a kilogram per millimeter, so there's around 100 kilograms of weight per square meter in the middle of that roof. So it's something that we need to remedy. This is what good falls look like. So you can see that the height of the upstand here is a lot less than the height of the upstand here. So we've got a good fall on this roof. That might be formed out of tapered insulation, or those falls could be within the deck. And again, that's something that we do need to establish when we're carrying out surveys. This is when there isn't enough fall on the roof. So you can see there's a pond here. This is a welted drip into an external gutter, and there's actually a backfall here, as you can see with the spirit level. Another common defect is condensation or condensation risk. It's not always a leaking roof. So let's make sure that we get those condensation risk analysis done. So interstitial condensation in a flat roof occurs when the warm, moist air inside the building passes through the roof deck and then condenses on wherever that cold part is from outside. So whether that be on the underside of the deck, whether that be on the underside of the roofing, the waterproofing material, that's where that condensation is going to occur. When we carry out condensation risk analysis, we look at where what's called the dew point. So the dew point again is where the warm air meets the cold air. That's where the dew or the condensation is going to form. So in this instance here, you can see between number 4 and 5, so on the underside of the plywood deck and between the built-up felt, we've got 2.7 grams of condensation in January. So that's what shows that in a condensation risk analysis. We would put a warm roof over the top of this if we could. The idea with a warm roof is to get that dew point within the insulation so that it's not going to cause condensation. So that's what we do when we carry out condensation risk analysis and U value calculations as well, to make sure that we're complying with building regulations. This is a single ply roof where the building owner had leaks, or what he thought was leaks, since day one. This is the original single ply. He then had a separation layer and a new layer of single ply over the top. Then they patched the roof up with liquids and everything. Then they brought us in to have a look at it, and we found that there wasn't, as you can see there isn't a vapor barrier or an AVCL in place. It's a metal deck, so you could say, is it a sealed metal deck? Well, it wasn't, because there's M&E equipment and everything penetrating this metal deck, so there should be an AVCL in place. So this is what we found when we do that. Again, condensation risk analysis. We found that it's an unsealed metal deck with 50 mil of foil faced insulation. You can see why he was getting drips and everything coming through the roof. So there's 27 grams per square meter, or 135 grams per square meter of condensation within that roof buildup, and that's dripping back into the building. Okay, we're on the home straight. Causes of these common defects: well, poor design, wind uplift calculations not done correctly or not done, condensation risk analysis, U value calculations, let's say, or poor material selection. Like I said before, horses for courses. So we make sure that you specify the right material in the right situation. Poor installation, probably the most common cause of these defects. And the other one really that we've not touched on is lack of inspection or maintenance. These roofs, according to British standards and according to most manufacturer specifications, should be inspected at least every 12 months. And a lot of those inspections would stop a lot of these defects happening. Blocked outlets. And again, when we unblock the outlet, we find that the felt is delaminating and everything. So if this roof was inspected, those leaks perhaps wouldn't have happened, because that outlet there would have been free flowing. It's not a green roof, it's just a lack of maintenance, and these roots are going to cause problems, especially from like the likes of this buddleia kind of thing. Those roots are particularly bad when it gets into the laps and everything of waterproofing. So like I said, lack of maintenance, lack of inspection. Just clearing the outlets can make a difference, and making sure that we carry out those annual kind of inspections, get rid of all the leaves, get rid of the debris, just give it a check. These 25-year guarantees are put in place for a reason, but one of those clauses that we'll find within more or less all of the manufacturer's system guarantees the clause is that the building owner should carry out maintenance or inspections in line with BS 6229. So those kind of warranty inspections are really important, because if you come to year 5 and the roof leaks, and the manufacturer comes out and says, show me the evidence of your annual warranty inspections, and you haven't got them, then immediately they've got a get out clause there for their guarantee. So it's one of our services is warranty inspections. We do a lot of them, and liaise with the manufacturers and get things put right before they go catastrophically wrong. Okay, relevant documentation when looking at flat roofs. BS 6229 is the British standard for flat roofing. So familiarise yourself with it or not, just give me a shout. BS 5250 is the management of moisture in buildings. So that's where we're going to get our condensation risk and everything like that from. And building regulations L2B, which is being updated. I believe it might have been updated, so it's just part L now. And that's going to tell you your U values and things like that for flat roofs. Some other kind of courses that I've got available for CPDs. If you want to get in touch, then obviously I can deliver these to either yourselves personally, your practices, direct, face-to-face or online. If you don't want to go out there and look for the common defects yourself, as you say, you've probably seen me running around roofs on LinkedIn. I get quite excited and passionate about doing these surveys. Give me a shout. I can jump on the roof for you, do physical surveys, drone surveys with moisture mapping, electronic leak detection, obviously put all of that together and in a condition survey, put together a specification for you, the right material selection, the right calculations, and then we can look after the project as well for you, and even carry out those warranty inspections so that you don't have to worry about it, and you don't have to worry about invalidating your manufacturer's guarantees. Okay, there's my contact details. If you've got any questions, give me a call. Don't mind taking questions over the phone. Even if it's just a bit of advice, just give me a shout or drop me an email. If you've got a roof that you want me to have a look at for you and carry out any of those services, then again, give me a shout. I'll leave those